All right. Good night. Good night. My name is Brian Joan Roca, and today I'm gonna be presenting on the eccentricity of a hyperbola. Specifically, what happens as the eccentricity approaches 1 in a hyperbola and infinity in a hyperbola. So first of all, we're gonna start off with this equation, which is the equation of the eccentricity of a conic. So the eccentricity is equals to c, where c is the distance between the origin and a focus, and all divided by a, where a is just the distance between the center and a vertex, right? So in a hyperbola, we learned in class that c is equals to the square root of a squared plus b squared, right? Well, that actually leads us to this fact, where all we're going to do is we're going to take the c inside of the hyperbola and put it into the c of the eccentricity formula, and what we'll get is that the eccentricity of a hyperbola is equals to the square root of a squared plus b squared, all divided by a, right? Now hopefully it is very easy to see actually that as b approaches 0, this b essentially becomes negligible, and you'll just be left with a squared over a. So as b approaches 0, the eccentricity actually, sorry for the middle finger, no, sorry, the eccentricity approaches 1. Yeah, this has very big implications, because this essentially means that the eccentricity approaching 1 is actually just a squish of the hyperbola. So like this. So here we just have a regular hyperbola. Just, you can see that this asymptote here is just made up of the distance a and b, where this slant is just b over a, right? And in a hyperbola that its eccentricity approaches 1, b approaches 0. So b over a gets closer and closer to being 0, because it gets closer to being 0 over a, right? Which just means that the line or the asymptote gets closer and closer to being a horizontal line, meaning that the hyperbola actually squishes. It becomes closer and closer to a line. Now, using this same mathematical method that we used to get this one, we could actually see that as b approaches infinity, the eccentricity approaches infinity, because you essentially get the square root of a squared plus infinity all divided by a. This just approaches infinity. It's just a very, very large number that approaches, right? And because of this, we can see that eccentricity approaches infinity, b has to approach infinity, which gives us a graph that looks like this. So this is just a regular graph, where we can see again that it's just that the asymptotes are just made up of b over a, and well, in one where b, in a hyperbola where b is greater, the eccentricity is greater, meaning that b is higher. So the asymptotes actually become much steeper, and eventually they actually approach 1. The asymptotes approach being just like almost straight lines almost. So you can see that the hyperbola actually kind of stretches out on the y-axis. It becomes very, very elongated on the y-axis. Yeah. So to conclude, as the eccentricity approaches 1, the hyperbola approaches being a line, because the asymptotes approach being having a gradient of 0. And as the eccentricity approaches infinity, the asymptotes approach being straight lines. So the hyperbola will actually stretch on the y-axis, given that the formula is x squared over a minus b squared over, but minus y squared over b squared, over a squared for the x. All right, well, thank you.